Alright, the pulleys we're looking at now, we're going to assume do not have a mass. So these become simple systems of equations. So let's say mass 2 is larger than mass 1. So we believe that the acceleration is going to be this way. So we're going to make that direction positive. So then straight down is force gravity. And upwards is force tension. And since the pulley does not have any mass at all, force tension on this side is going to be the same. But from the perspective of this box, we'll have force gravity this way. And upwards this way, force tension. So then if I write the net force equation on this, we're going to have M2A equals M2G minus force tension. And this one's going to be M1A for this box equals force tension minus M1 times G. All you gotta do is add both equations together. Your tension forces will cross off, and you can solve for the acceleration, which will be the same for both, and then plug back into either one of these equations in order to get the tension forces value. Now, if we happen to change it to this system here, this box here, of course, is going to stay the same. So you have force gravity. And this, of course, is going to be force tension. The difference with this box here is you do have force tension going this way. But again, we'll have gravity downwards and normal upwards like usual. I'm not going to label those. We know what those are. And then you're going to have force friction this way. So this equation will stay the same, force tension and force gravity. So we'll have MA equals mg minus force tension. This one's going to change to MA equals force tension minus mg mu. And then you'll add the two equations together. Tension forces will cross off. And you can find acceleration just like you did before and tension like you did before. Now if we have, for instance, again, this box or this opposite here is going to stay the same. So we'll have force gravity downwards and force tension upwards. Now if you notice this time, it looks like things are accelerating this way. So if that's true, then the net force on this one here, we're going to write it a little differently. We're going to call this direction positive. So I'll have M2A equals force tension minus M2G. Now this box here, we're going to have force gravity X pulling downwards. And of course we'll have force tension. And another vector going this way of force friction. So this equation here, I'll try to write this quickly, is going to be M1A equals mg sine theta minus force tension minus mg cosine theta mu. We'll add those two equations together. Force tensions will cross off just like always. You get the acceleration, then plug back into either equation, and you will get the tension force. Now this one here, I typically see this more in Physics C. This one involves the systems of equations because you have a box in between. So you'll have force gravity, and then this one here will be force tension 1. Then we'll have a force tension 1 pushing this way. And then this one is going to be a force tension 2 pulling this way. And straight down for this one would be force gravity and force tension too. Okay, so this box here, I'm going to see an mg downwards and a force tension upwards. So let's say it looks to me like we're going to get an acceleration this direction here. So the net force on this one's going to be 2a equals force tension minus 2 times 9.8. This one is going to be 4a equals 4 times 9.8 minus force tension 2, and that's going to equal ma. This box here will be our third equation because we have two unknowns. So this one's going to be then force tension 2 minus force tension 1 minus force friction equals ma, because there'll be a friction force also on this one. Let me draw that vector there too. Force friction. And force friction again is equal to mg mu. So this one's more I see in the mechanics C, not AP Physics 1, but there will be a gravity downwards and a normal upwards on this one. So if they do put a third box in the middle, these two tension forces are not the same because this is affecting what's going on. So you do need three equations, one for this one for this one, and the last one will be this equation here. So that is a pretty good review of our pulleys. Just one more quick example. What if you have a systems of pulleys here? I just want to remind you that there will be for this pulley, a tension this way. Okay, and then of course, from this perspective, there'll be another force tension this way. And then of course, there's going to be a tension force on this one here. So my point is, this one's going to feel two tension forces on it, and this one will feel two tension forces on it. And I'm assuming that none of these pulleys have masses this time, so we get a doubling effect of the tension forces acting on the objects because there's two strings instead of just one. So I just wanted to do that quick reminder about that. All right, so that's our pulley systems.